Hello everyone, I'm here representing Boston Scientific, and today we are going to talk about our capstone project, the Market Gap Assessment Tool. I'd like to give a big thanks to our technical directors, Prashant Somu and Kevin Bagley, who have been giving us very valuable insight all semester long. I'd also like to give a big thanks to our consulting technical director, Justin Watkins. The team composition is me, Zachary Nitariani. I am a computer engineer, as well as Samir Rahab, who is also a computer engineer. The overview of Boston Scientific is they're a big company in the medical technology field. They do a lot of investing in R&D with developing these technologies. They also help treat patients every year using these technologies and new procedures. The motivation for this project is that this field is always growing, always expanding. So new technology procedures always come up. So our solution is the market gap assessment tool, which is able to gather this data in real time and make predictive analysis on what is new and happening in the field and provide that to the user. The AVO of our project is a UI that is very easy to use. Also, the predictive feature that pretty much can take new ideas, new technologies, and make an analysis on whether it should be valuable or not to the company. It should be aware of all new things happening in the field, so it should be completely aware of new technologies popping up every day, every week. It should also be customizable, so if it needs to be improved on in the future, it should be very easy to do so, and it should be efficient. So this should be very quick, and the AI should be able to make accurate and also innovative decisions. Our team accomplishments to date is a UI schematic. We have programmed detailed user-friendly design. We have web scrapers that pull data from various sources. We then store this data, which is used for querying and then training in the future. We also have designed scalable architecture so that it's very easy to add or remove features as we see fit. The impact for this company is very big. It allowed them to stay on top of their competitors by pulling up these new information and new facts to make decisions much quicker than any of their competitors would be able to. So to go over my portion of the project workflow, from my end, we'll be talking about the back end of this project. And my individual technical contributions so far is I've done a lot about LLM or large language model background research. I've done a lot of research for web scraping in the pipeline to implement them. So taking data from web scraping and then implementing them into the LLM, as well as data storage management, since it will be a very big project. Storing this data will be very valuable for the future. I'd like to start by talking about the web scrapers. We pull from two main websites, the FDA database, which has a large collection of other smaller databases such as MAUDE, the PMA, pre-market approval, recalls, and 510K, as well as PubMed, which is a very large collection of medical technology research papers. We also use API keys, which take from Arxiv, which is just a large collection of research papers in general, and News API, which has a bunch of news resources inside of it. How the web scraping tools work is when we're pulling from the websites, it is able to identify the structure of the page, so look at the HTML, and then it moves on to the next step, and it gathers the data based on the user query from the HTML. We then check to make sure the right data is obtained, and if it is, then we can move on to the next step, the AI filter results. If not, then we have to go back and optimize the script to make sure that it gathers the data that we want. When moving on to the AI filter results, this step is very important to make sure the user gets data that is relevant to what they ask for. So if an article is too out of date, it's able to filter through that. If the article is not relevant to what the user asked for, then we don't send it. And it also save links or save entities that it sees that may be able to be used in the future. It can do that and then store that as well. And then it filters through HTML structure, as it can be pretty messy, which I'll get into the next slide. And when it's done, it sends it to the database to be stored, then also sends it to the next step, the generative AI. And this is an example of a search on the left from the MAUDE database. So there's a lot of information here, but really, we really just want the event description. On the right is where the event description is in the HTML side of things. So this big paragraph right here is the event description, but along with it comes a lot of HTML structure that is unnecessary and that the user doesn't need to see. So this step helps filter out all this unnecessary data. Moving on to the next step, the generative AI step. It is an AI model that is tasked with taking in the user's question. It is also tasked with presenting the results to the user. So when taking in the user query, it can help fix grammar mistakes or spelling mistakes. It can split the question to multiple parts. If the user asks two different questions in one search bar, it's able to split that question into two different search terms, which will help gather better results. And then the AI is able to put these two results together to give it back to the user. And you can also fill in information. So if the user is not very descriptive at all, or if the user doesn't give, a certain time frame, it's able to fill in this information to get more concise results. And then when sending the results back to the user to display the results, this step using AI allows for more conversation, so a user can clarify in the results. The user can ask to retrieve more information from the database if needed to help clarify. It can also take user feedback, which Sam will talk about in the future. In my future individual technical contributions, we'll be implementing an advanced AI model. So this AI model should be up to date on all information. It's to be able to have these advanced predictive capabilities. And to implement that, we'd like to use a graph RAG algorithm, which will really be able to help graph entities and relationships between terms. And this will help with the predictive capabilities. We also would like to develop a query path optimization. So this allows the AI to pretty much go down its own search path. If it sees an entity that it thinks might be able to help contribute to the user's query, it's able to search for it on its own and then provide that information back to the user, all doing that on its own so the user doesn't have to do that themselves. And now I'd like to pass the project over to Sanya Rahab, who would talk about his contributions.
Hello, my name is Samuel Rahib, and I will now go over my contributions to the project, which is mainly the UI design. And I will now go into that further. So, my individual contributions, like I said, mainly is the UI, so that includes UI wireframes, which, for those who do not know, wireframes are essentially just schematics. And I also programmed both the search page and the results page, as well as optimizing these UIs, which is essentially just making them work on whatever device or screen size that the user is using. And so how this works in depth is once the UI eventually connects to the backend, the user will take the action of entering in a search query, and this then goes to the backend where it gathers data using our AI, which would work to retrieve stored data from past uses as well as find new relevant data for the search. It would then filter this data into a generalized output that would be put onto the displayed results. And this area for displayed results also lets the user take the action of providing extra feedback, which would allow the AI to make follow-up responses. And finally, the user is able to flag specific topics that they want the AI to save and consistently update with the latest information. And so this is the wireframe for the search page. You can see it has the subscribed topics that the user has flagged, as well as recommended topics where they can like or dislike by using the check mark and the X. There's also the subscribed topics on the left saved and the recent searches that the user has made. This is just great for easy access. And then finally, there's the search query at the top where the user is able to enter in what they want to search, as well as provide a specific category of their search to make sure that the AI is only providing the most accurate information relevant to whatever the user is searching. And so this is the first iteration of the search page. You can see there is the subscribe topics on the bottom where it has the recommended topic with the check mark and the X. And they can click on whatever one they want and it will open it up into the results page, which you'll see later. And then there's also the subscribe topics and the recent searches on the left in the sidebar. And then as well as the search bar at the top for any new search query, as well as the filter button, which was changed from the category button. So now with the filter, you can also do the category, and you can now also do a specific dates. So a start date and an end date. This is great for making sure that the AI does not pull any information that's too old and now invalid, or information that's too new where it may not be backed up yet and potentially invalid as well. So this is the results page wireframe where it still has the sidebar for the subscribe topics and recent searches where the user can easily access them, as well as the search bar at the top with the category button, which is now the filter button for any new searches, as well as a block of text in the center for the AI's generalized output. And there is also a sources button on the right where when the user presses that, it will list out the specific sources that the AI used to formulate its response. And if you press a specific source from that, then it will bring up a generalized piece of text going into what information was pulled from that source and why it was useful. And the user can then rate that information on whether or not it was helpful. And so this is the first iteration of the results page where you can see it maintained the subscribe topics and recent searches sidebar. The filter button is now there instead of the category button. and it has the generalized output in the center with a title and the sources sidebar as well. And there's now also a additional bar at the bottom for any follow-up responses that the user might have for the AI. So now for my future contributions, I would like to do backend integration where I connect the front end to the backend to overall make the AI bot functional. And so I would also like to do data connection and analysis by using social media bots. And so these are amazing for scraping online forums. And so we would specifically like to do medical forums, which leads to my next point of insight generation. And so for this, the information that is pulled with the social media bots, I would use that to train the AI with sentiment and outlier analysis. And so sentiment analysis is great for the AI to be able to understand good from bad or positive from negative. And outlier analysis helps to find anomalies in data, which is great for highlighting any emerging trends. And so I would like to use this in our AI tool, as it would be great for helping the bot and in turn helping our team to stay ahead of the curve and be able to spot key patterns that people would just normally miss. And so finally, I want to enhance our UI that we already have to make it less blocky and just more sleek and enjoyable for the user. And so future accomplishments that we want to make as a team, we want to be able to develop an adaptive AI. So this would essentially be an AI that would learn and evolve over time rather than working off of just fixed rules and models like how a traditional AI works. We also want to advance the UI to make it so that the user always has a seamless, enjoyable experience whenever they're using this tool. And we want to be able to also make this project scalable. So in other words, if somebody were to join in on this project, they could work on it and approve it without having any trouble. And so finally, like I mentioned earlier, I want to be able to use social media analysis so that the AI can understand trends and audience behavior as well as emotion across several platforms. And so finally, I want to give another thank you to our technical directors, Prashant and Kevin, as well as a thank you to our consulting technical director, Justin, and a thank you to our capstone director, Dr. Sunak. Thank you.